All right, we're on to part 3 now, and the first thing I ask you to do is to insert a new map frame. So again, remember, insert, new map, and so we click on that, new map frame, and we'll open that up. We're going to keep our table of contents over here. And again, what I'd like you to do is on the map, we're going to rename it. So we're going to go to its properties. And in this one, what we're going to do is we're going to name this map land cover. And so again, we go right up here and we put in land cover and apply and OK. And now we see it here. You can hear my dog in the background. I apologize for that. Okay. And then next, I'm asking you to add this data set here, which is the USA Annual Land Cover data set. And so we're going to simply take that one here, and we're going to drag it over. And one of the first things you'll notice when I do this, and again, it's important the order that you add things to a map. When I've added this, what it has actually done is changed the coordinate system and the projection of the map frame to match it. And then what I'm going to ask you to do is add from our folder in our week 8 resources geodatabase the PA counties. We're going to drag that over it. And then because I want to see where the counties are in relation to this, what I'm going to do is I'm going to right click on it, go to its symbology, and what I'm going to encourage you to do is change this to a hollow, and I'm going to use a thick black hollow outline. That one seems appropriate. And so now I can actually see the counties that I'm going to be working with. The next thing that I want to do, and one of the things we can do, because again, this is categorical data, I can right click on this and open its attribute table. And what I want you to note is that, for example, open water, what this is telling us is that we have a value of 11. That's what's stored actually in a pixel. There are 717,000 pixels, 1,717,819 pixels of open water. Now, what we have to also, though, think about here is, again, getting back to any raster data set, one of the first things we should do is look at its properties. And in this data set, our units are meters. Okay, so again, you'll notice down here it also says meters. If I look at the spatial reference for this, you'll notice that it is an Albers. It is a projected data set. Albers, the AEA is Albers equal area, and it is a WGS 84. And so again, if we scroll down, what you'll notice is in this case, there is no vertical datum because it's not data that would have one. Again, this is categorical data for land cover, not elevation data. So again, we've got our things here. The other thing that we should pay attention to is our raster information. If I click on that, you'll notice here one of the really important things is that the cell size. All right, I apologize, dog was making noise there. What we're looking at now, one of the things I want to note about this raster data set is that the cells are not actually square, they're rectangular. And this sometimes happens when we have data that's moved across different projection properties, especially when geographic data is projected, we end up with some interesting things happening. So it's important to know that. So again, it's 37 meters, 37.88 meters by 47.09 meters. And again, it's important to know, but when areas are calculated, they will calculate correctly in this. And so again, we're going to click OK. And so that will help us answer some of our questions. What we're going to be doing next is a way of taking raster data and using it to calculate area when it's very complex, when some phenomena, some categorical data, like land cover, is very complex within an area, in this case, counties. And so again, what we're going to be doing is we're going to be using the tabulate area tool. And that's very important in terms of working with raster data, and especially categorical raster data. So again, click on our analysis tool, and we're going to type in tabulate area. And here it is. And we're going to click on it. Notice that there are other ones that are tabulate, but we want tabulate area. And so our input raster, okay, and again, so what we want to think about here is the first one is the feature zone. So in other words, those are the features that we want to get information for. And so in this case, we want it to be the counties. The zone name is going to be the name of the county. The input raster feature then is going to be our land cover data. The value field that we actually want is the class name. It makes it a little bit easier. You could, by the way, notice there's a kind of a special tool here. It says classes as rows in output table. The only reason you would do that is if you wanted to then move this into an Excel table. Sometimes using it as rows is very useful when what you're getting out goes into a pivot table. But here, we're going to use the processing cell size as land cover. And so everything here looks good. We're going to click on our environments to check if there's anything we want. And here, I want to talk about a couple of things that happen. So first of all, processing extent means where the analysis is going to occur. And in this case, what I want to use is the PA counties. I don't want it going any farther than the PA counties. The next thing that I'm going to do, and remember we talked about no data, I'm going to apply a mask that is also the PA counties. And that means that anything outside of them will be calculated or observed as no data in this. So we've got all these pieces in play. We know where we want it to go. And again, this is going to create a table. That will be a standalone table. And I'm going to click Run. And again, this will take just a few minutes. And now, when I'm going to close this tool, you'll notice over here in my table of contents, there's a new area that's called standalone tables. And that's the tabulate PA right here. And I'm going to right click on that and I'm going to open the table. What you'll notice is that each county is listed as a row. And again, there are 67 counties in Pennsylvania. And then across the top are the land cover classes. Now, what I've asked you to do is to, for example, the first question says, which county has the largest area of deciduous forest? Well, what I simply have to do is look for deciduous forest, that's right here, and I'm going to right click on that field and then sort descending. When I do that, what shows up as the highest one is Potter County. And again, that's not surprising, that's Allegheny National Forest. And so that answers your first question. And then I can do the same thing if I go to developed high intensity, and again, sort descending. And again, now it's Philadelphia County. Not surprisingly, Allegheny County comes in a close second. And so this allows us to, in a sense, examine different land cover types as they relate to counties. And I could do that for any one of these. Later on, we'll also look at how we can do this with a histogram or to create a table from this. Okay, the next thing that I'm asking you to do, and I'm going to close this table, is to work with a basic map algebra or raster calculator tool. And so the raster calculators, again, under analysis, click on table, and the raster calculator is really just that. It is a tool in the spatial analyst. You notice that it exists in both image analyst and in spatial analyst. We're doing spatial data, so we're going to click on the raster calculator there. And what I want to do here, this is a really important idea, unfortunately, is that I want to add, notice that this one has a little, if you will, a little yellow-like piece of paper. We actually don't want to use that one. What we want to use is the actual data set. So I'm going to take that data set and I'm going to add it to this. And so again, I can do that here, add raster to it. And again, if I go up to my databases and my folders, Wikate resources, you'll notice that it's right here. And I'm going to add that. And now I'm going to use that one. Some of you had that problem. Again, use the actual raster data set, not the layer file. And that's what this yellow thing is here. And so what I want to do now is I'm looking specifically for deciduous forest. And so deciduous forest is number 41, I believe. We're going to check that real quick. And if we open up that table, we should see, yep, it's 41. And so what I'm going to do here is click this, and then remember that this is Python, so then I've got to put in 2 equals signs, and then I'm going to put in the number 41. Notice that I have to put in a number and not deciduous forest. The number is the value that is stored in the cells. The deciduous forest, that word, is stored in the attribute table. And then what I've asked you to do here is to name this. I believe I've asked you to name the output from this. I think, I'm going to have to look and make sure. Again, just like you, I have to make sure I'm doing the right things. And we're going to call the output deciduous. So again, we're going to replace all of this with deciduous and click run. And again, I could have done the same thing in terms of my environments. I could have used a mosaic or a clip and a processing extent. And now what we get, and I'm going to turn this off, you'll notice here that you get 2 values. You get zeros where it's not deciduous forest and 1 where it is deciduous forest. So in other words, true and false. And we also get a whole bunch of stuff on the outside that is also false. And so again, if we zoom in, we can see, and I'm going to look right in this area here. Notice if I turn this off and we're going to see what's underneath it, that in fact it is showing the deciduous forest, and actually right here you can see the evergreen forest. And so again, that allows us to, in a sense, extract a single part of a categorical data set. Okay, that's it for part 3. We'll be back with part 4.